Hi, I'm Dr. Jessica Stokes, a postdoc at the Pirbright Institute. Today I'm going to talk to you about persistence in the face of absenteeism, and to do this I will be covering work completed as part of my PhD at the University of Liverpool on Schmallenberg virus, followed by some of my more recent work here at the Pirbright Institute. First of all, I must introduce Culicoides biting midges. Although they're not the only vector that I study, they are most certainly the most challenging. Here in the UK, we have approximately 50 different species of Culicoides, which we can mostly speciate based on their wing patterns. They are between 1 to 3 millimeters in size, and only the female consumes a blood meal. Regardless of their small size, Culicoides represent a significant biting nuisance and transmit several economically important diseases of livestock. Despite their abundance and keenness to bite in the field, efforts to colonize Culicoides biting midges are limited to Culicoides sonorensis, an American vector species, which I suspect you will hear more about in the next presentation, and this is the midge closest to the wing pattern sheet on the slide, and Culicoides nuberculosis, a British species, typically not considered a vector species, which is the next one in. As you can see, both species are at the larger end of the midge scale, and we maintain colonies of both of these species here at the Pirbright Institute. In terms of disease vectors in the UK, the main species implicated are those within the morphometrically cryptic obsoletus group, the smallest midge in this picture, and includes Culicoides obsoletus, Culicoides scoticus, Culicoides dwarfi, and Culicoides chiopteris. A lesser extent, those within the Culicoides group are also considered vector species, and that's the second midge in on the picture. These species are all extremely common and highly abundant throughout the UK, particularly on farms. This pot holds a catch from just one night, and next to it are two sorted catches from the same dairy farm collected the previous evenings. This represents well over 1,000 midges and is a pretty typical catch for us on a favourable trapping night. So what are some of the challenges working with midges? Well, these are my top picks, but there are many more. Their small size makes them challenging to work with from both a handling and a containment perspective. We are reliant on parity as a proxy for age, which is not ideal. However, we are currently working on this. We have an inability to colonize UK vector species, and UK vector species have both a relatively low survival rate and low feeding rate within captivity, which makes transmission studies infinitely harder and seasonally based, hence why we tend to rely on colony species for our initial groundwork. Vector competency within the population can also be low despite their high capacity in the field. This is due to high abundance and biting pressure, which makes transmission studies more expensive and typically necessitates pooling samples and the application of high throughput techniques. And to top it off, our main vector species in the UK are morphometrically cryptic and have varying vector competencies. If you're interested in finding out more about how we identify and trap midges, please check out our free resources produced and hosted on the network. Now that I've introduced you to the vectors and their challenges, let me introduce you to some of their diseases. Back in 2011, a completely novel Orthobunyavirus emerged along the German-Netherlands border, subsequently named after the region the first samples tested originated. Schmallenberg virus spread quickly, with reports rapidly emerging across Europe. Within just 3 months of initial discovery, it was detected in the south of England. Culicoides biting midges of the obsoletus and Culicoides groups were quickly confirmed vectors, with minimum infection rates reported between 0.1 and 4% from field caught collections across Europe. Adult ruminants are typically asymptomatic, with only very mild clinical signs reported in cattle. However, if an animal is infected for the first time during the vulnerable period of gestation, infection results in abortions, stillbirths, and fetal malformations. Indeed, in 2012, many livestock losses were reported across Europe. In the UK, Schmallenberg virus was designated non-notifiable. This meant that we relied on the voluntary reporting and submission of suspected cases to the Animal and Plant Health Agency, formerly the AHVLA. In both 2012 and 2013, there were many reported cases across the UK, which were subsequently confirmed positive for Schmallenberg virus by the APHA. In October 2014, I started my PhD on the between and within farm transmission dynamics of Schmallenberg virus. Coincidentally, in 2014, reports of Schmallenberg virus all but dried up, making recruitment for a within farm transmission study extremely difficult. This had me wondering, were farmers just used to Schmallenberg virus now and no longer reporting what they had already seen, or had Schmallenberg virus disappeared? To answer this question, I decided to design a freedom from disease study in case Schmallenberg virus did not reappear during the 3 years I had to complete my PhD. I focused on the southernmost counties of England, as all of these counties had reported cases in 2012 and 2013. They are also the most at risk from ongoing incursions of potentially infected midges blown across from Europe. I hold a personal license for collecting blood from sheep, so we focused on sheep flocks. I stratified sampling by county based on the 2010 census by the Department for Environment, Food and Rural Affairs, which I had access to through another project, and completed a two-stage cluster analysis in the R package FFD. This determined that I would need to sample 11 sheep per farm from 131 farms. To allow for any failures during sampling, I increased this to 12 sheep per farm. These sheep needed to be between 6 months and 1 year old at the time of sampling, so that they were only alive and therefore only exposed during the 2015 vector period, and to avoid any maternal antibodies. Recruiting 131 sheep farms from about 200 miles away is logistically challenging. I quickly worked out the most efficient way was for me to advertise the study in person at sheep shows, allowing farmers to ask questions, be reassured, sign up, and recruit their friends all at the same time. I cannot stress enough how important clear communication is, particularly with farmers who are giving up their valuable time and experience for free. This meant agreeing dates and times in advance, arriving when I said I would, being efficient on farm by having everything pre-counted and pre-labeled, and recognizing all of the different sheep breeds we have here in the UK. Sampling was intensive. I would aim to complete 5 to 10 farms in one day, depending on location, and I'd come down for several days of collections before returning to Liverpool to test the samples. This necessitated a car fridge, lots of planning, lots of sofa surfing, and a lot of friends who were very calm about me storing bloods in their fridge. In all, it took me about 3 months to complete the collections and testing, and I was done just before Christmas in 2015. After ELISA and confirmatory virus neutralization testing, all samples were determined negative for Schmallenberg virus antibodies. We published this in the veterinary record with the print version published in October 2016, highlighting this very large naive population at risk from reinfection. In December 2016, 9 UK holdings tested positive for Schmallenberg virus. Entering the final 9 months of my PhD, Schmallenberg virus was back. I decided I probably couldn't ignore this reemergence, so along with collaborators at the APHA and University of Nottingham, we created a survey to determine the impact of this second outbreak, which we could directly compare to a previously published survey conducted in 2012. This persistence paid off, and we published the results demonstrating a highly comparable impact to the original outbreak. In particular, this study highlighted the economic, social, and animal welfare costs of Schmallenberg virus on the individual farms that had suffered from malformations within their flocks, despite the significantly lower coverage in the media. Having completed my PhD, I moved to the Pirbright Institute to continue working with Culicoides, including studies on their overwinter activity and seasonality of emergence. This has been going very well. Even in winter, you can catch the odd midge. Then it was suggested we conduct an investigation into the vectors of bovine ephemeral fever virus, along with colleagues at the APHA. Bovine ephemeral fever virus is a rhabdovirus, which does what it says on the tin. It causes fever in cattle. Outbreaks of BFV in Africa, Australia, Asia, and the Middle East are characterized by high rates of morbidity and highly efficient transmission between cattle hosts. Despite this, the vectors of BFV remain poorly defined. This is largely due to the transient nature of the disease in the wild, along with difficulties in culturing infectious virus in tissue culture. Here at Pirbright, we benefit from a SAPO4-CL3 arthropod infection suite along with animal isolation units, allowing us to complete infectivity studies in both the insect vector and animal host. This allowed us the opportunity to test the infectivity of the tissue-cultured BFV to different potential vectors, which, if we successfully demonstrated infection, would allow us to develop a more natural in vivo onward transmission model. My experience working with Culicoides has taught me to persist, and that negative results are still important and valuable for filling in the picture for neglected vector species and their diseases. There are some really great resources out there, and I have benefited from working with some really fantastic collaborators, all of whom I would like to thank. I would also like to acknowledge the hard work of my colleagues at the Pirbright Institute, in particular the long days and hard work of Chris, Karen and Simon on the BEFV project. Thank you for listening.